Hi, we are now in geometric sequence, and as previously, I will use GS to represent geometric sequence throughout the video. So in a geometric sequence, each term is found by multiplying the previous term by a constant. For example, we have, this is an ascending order of geometric sequence, 2, 4, 8, 16, and so on. And you can see here that each term is a multiply of 2 from the previous term. So generally, we can write a geometric sequence as A, AR, AR squared, AR cubed, and so on, with A, its first term, and R, the common ratio, with R equals to Tn plus 1 over Tn. And n here is also a positive integer. The nth term of our GS is given by Tn equals to a dot r to power n minus 1. We also have two formulas for partial sums of GS with r less than 1 or r greater than 1 correspondingly. And in GS, we have sum to infinity with the formula a over 1 minus r. Now let us look at example 9. Find the general term, which is Tn, for the geometric sequence given. So we have an ascending order of GS here with A, the first term, equals to 8 and R equals to 16 over 8, which is 2. So general term here is Tn equals to A dot R to power n minus 1. And substituting our A and R we found previously, we have 8 times 2 to power n minus 1, and simplify it, we have Tn as 2 to power n plus 2. And we're done. For example 10, we have to find the ninth term of the GS for 27, 9, 3, and so on. So this is definitely a descending order. So we have here A is 27 and R is 1 over 3. As previously, we have to use the Tn formula, but this time you have to substitute in our n equals to 9. And with A and R, as we find here, to get 27 times 1 over 3 to power 9 minus 1, which is equal to 1 over 2, 4, 3. And we are done. For example 12, we are to find the sum of the geometric series 1, 1 over 2, 1 over 4, up to 1 over 2, 5, 6. The sum of a geometric series is Sn. So we can obviously see from this sequence, we have A equals to 1 and R equals to 1 over 2. They give us the final term, which is 1 over 2, 5, 6. But we do not know which n gives our final term. So here we write down our last term as Tn equals to 1 over 2, 5, 6. In order to find the sum of the first n term, we first need to find our n. So to do that, we have to use the Tn formula again with our A, 1 and R, 1 over 2, and equate it to 1 over 2, 5, 6. And finding the same base for both sides of the equation, we have 1 over 2 to power n minus 1 equals to 1 over 2 to power 8. And comparing the indices, we have n equals to 9. Now we know that the last term is 9, then we can find the sum of the first 9 terms of this geometric series. And to do that, we have to use the formula for Sn for r less than 1 or less than 1, and substitute a, r, and n to get 511 over 256. And we're done. Now look at example 13. The sum of the first two terms of the geometric sequence is 36, and the product of the first and the third term is 9 times the second term. And we are to find the first 8 term, which is, in this case, S8. So as we can see here, there is no sequence given to us, so we do not know our A, and hence we cannot know our R. So we first let our sequence in general form, which is A, AR, AR squared, and so on. So taking out the information given to us, the sum of the first two terms is 36. So we have A plus AR equals to 36. And the second one, the product of the first and the third terms is 9 times the second term. So here we have A times AR squared equals to 9AR. Simplifying it, we have AR equals to 9. So we have second equation. So we have to solve these two equations simultaneously. And by using the method of substitution, we substitute 2 into 1 to get our A equals to 27 and R equals to 1 over 3. So after finding A and R, we can then find our S8 as the question asked. So to do this, we have to use the formula for R less than 1 and substitute our A 27, R 1 over 3, and N equals to A. And then calculating this formula, we will have S8 as 3280 over 81. And we are done.